Welcome back. In this section, we will look at homologous series. So remember, we have been talking about four families of organic compounds. We said we have the alkanes, we have the alkenes, we have the alcohols, and then we have carboxylic acid. So each family is a homologous series. Very simple. There is a homologous series, there is another homologous series, there is another homologous series. So, then what are homologous series? A homologous series is a family of organic compounds with the same functional groups. They are going to have the same functional group. So, because they have the same functional group, they will have similar chemical properties. Remember, I said it is a homologous series, it is a homologous series, it is a homologous series, and that is a homologous series. So any member of each series will have these properties. That is, they'll have the same functional group, and then they will react alike. They have similar chemical reaction or chemical properties. So let's look at one homologous series quickly before we look at the properties generally. Uh, when we say, let's look at the alkanes. So this is a homologous series. So these are the members. We said a series, a family of organic compounds that have the same functional group. So a family member of this is CH4. Another family member is C2H6. Another family member is C3H8, and then C4H10. So these are the families of these alkanes. So this is a homologous series altogether. So what do they have in common? We look at their properties one by one, so we'll understand what homologous series means in a deeper way. So they may ask you to state the properties of homologous series. The first one is they have the same general molecular formula. Same general molecular formula. So when we say general molecular formula, it means from a single molecular formula, you can derive the family of each member of that homologous series. For example, let's look at alkane first. The alkanes, the general molecular formula for the alkane homologous series is CnH2n plus 2. So this formula, you can derive the formula of all the alkane family member from this formula. So for example, what does this N stand for? N stands for number of carbon atoms. So it means if N equals 1, what is going to be the family member? So we just substitute N with 1 in this general molecular formula. So it's going to be C1 H2 times 1, 2 plus 2, 4. So because it is 1, we don't need to write it. So that is CH4. So if N equals 1, it will give you CH4, which is the first family member of the alkane, that is methane. So let's look at the next family member. If N equals 2, what do we get? N equals 2, we are going to get C2, H2 times 2, that's 4, plus 2, 6. That is ethane, remember. N equals 3, we are going to have C3, H, 3 times 2, 6 plus 2, that's 8. So let's take another homologous series. So that's one of the properties actually. Let's look at that of the alkenes. For alkene, if N equals 1, remember that the functional group of alkane is carbon to carbon double bond. So let's go have that behind your mind. If N equals 1, then the family will be C what? Sorry, I've not given you the general molecular formula for the alkane first. For the alkane, the general molecular formula is CnH2n. So that's all. So remember, N is number of carbon atoms. So if N equals 1, so the member will be what? C1H2, which is CH2. So as we have this CH2, do you think this one truly represents the alkenes? Because we said the functional group for the alkene family member is what? C double bond C. Carbon to carbon double bond. Remember, I call this one the signature for the alkene. So can we find that signature here? No, that is just CH2. CH2 cannot give you carbon to carbon double bond. So this is not the first family member of the alkene. The first family member of the alkene, let's go to N equals 2. If N equals 2, we are going to have C2H4. This is the first family member of the alkene. So there's nothing like CH2, which could have been methane. So there's no methane. No methane. So the first family member of alkene is what? C2H4, which is ethane. And then, of course, we have 2 carbon atoms now. So it means we can have our carbon to carbon double bond, and then we supply the hydrogen atoms to the carbon atom. So this is the first family member of the alkene. The second family member will be N equals 3 this time around, and that will be C3H6. The next one, N equals 4, it's going to be C4H8. So that is for the alkene homologous series. Remember, we're talking about the general molecular formula of the alkene, which is a property of a homologous series. So we can, okay, let's do for all of them. For the alcohol, which is alcohols, the general molecular formula for the alcohol is CnH2n plus 1 OH. OH. CH3OH. This is methanol. Remember, it will be methanol because we have only one carbon atom. N equals to, going to be C2H5OH, ethanol. N equals 3, C3H7OH, propanol. And for the next family member, which is going to be carboxylic acid, the general molecular formula for carboxylic acid is just like that of ethanoic acid. Sorry, it's just like that of alcohol, CnH2n plus 1. Instead of OH, it's going to be COOH. And the first family member, remember, must have one carbon atom. Or should have. We are expecting the first family member to have one carbon atom. So if you look here, we have a carbon atom here and another carbon atom here. So it means N equals 2, right? So we have 2 N. So let's just go. If N equals 1, what is going to be the family we are going to generate from this? It will be C, 2 times 1, 2 plus 1, that's 3, CH3, COOH. In this case, we have ethanoic acid, and ethanoic acid means there are 2 carbon atoms present. So it means there's a family member actually before the ethanoic acid where there is only one carbon atom, and that should be methanoic acid. So what is the formula for methanoic acid? That would be N equals 0. If N equals 0, it means this N is no longer there, That is, this carbon is no longer there. It's like C times 0. So anything times 0 is 0. So if n equals 0, this C is gone. So we have hydrogen. 2 times 0, that's 0, plus 1, 1. So we have one hydrogen atom, and then COOH. This is the first family member of the carboxylic acid, which is called methanoic acid. Meth, because there is only one carbon atom. And the next family member is when n equals 2, where we are going to have remember, C2. C2, H, 2 times 3, that's 6 plus 1, 7, H7, COOH. We have 3 carbon atoms when n equals 2. That is 2 carbon atoms here and then 1 carbon atom here. That is going to be what? Propanoic acid. So we have methanoic acid, we have ethanoic acid as the second family member, and then propanoic acid as the third family member. Remember, n is equals 0 for the first family member, n equals 1 for the second, and n equals 2 for the third family member of the of carboxylic acid. Remember, we are talking about the properties of homologous series, or the characteristics of the homologous series. The first one, we said they have the same general molecular formula. The second one, in this case, is the chain length of the family. That is, the chain length within a family increases by a constant unit, CH2. That is, I can write it as say the chain length increases by a constant unit, or you can just say by one CH2. So at a time, 1 CH2 unit at a time. So let us look at what I mean by chain length increasing by CH2. So let's take a family member. Let us take alcohol this time around. Alcohol family member, the first member is methanol, which is CH3, CH3OH. That's the first family member. The second family member is C2H5OH. The third family member is C3H7OH. We said the chain length increases by CH2. That is by one CH2. So what do we mean by that? One CH2 unit. So how do we get that from here? So we just look at this family and then compare it to the next family. And then we look at this one, we compare it to this. So let's just subtract the small family member from the big one. Here we have 1 carbon, here we have 2 carbon atoms. So it means this is smaller than this. This is smaller than this. So let us subtract them from each other, and then we look at we're going to find the chain length, how the chain length increases. So we have C2H5OH. Let us take away CH3OH from that. HO, we cancel O. When we take away H3 from H5, we have H2. We take away C from C2, we have CH2. So the difference between the first member and the next member is this CH2 unit. So let's look at that for the second and the third member. The third member is C3H7, H7, and then OH. The second member is C2H5OH. Of course, we can see that difference is there already. This is cancelled. And then when you remove H5 from H7, you have H2 left. And then you remove C2 from C3, you have C left. So it means the difference is also CH2. That is the property of homologous. If you take any family member, you do the same thing for the alkanes or for the alkenes or for the alcohol, you are going to have the difference in chain length to be CH2 unit. That is another property of the homologous series. The third one that we want to talk about of the properties of homologous series is the trend in their physical properties. So as the chain length gets longer, that is, as the chain length of the families in a homologous series gets longer, the melting and the boiling point increases. Remember, melting and boiling point, they are physical properties. So, and it makes sense actually. It makes sense because if you look at this, look at ethanol, and then look at propanol. So sorry, I said ethanol and propanol. So let make this one propanol, and then we make this one ethanol, OH. Okay, so this is a molecule of ethanol, and this is another molecule of propanol. So if I can make this one a little bit smaller, and then I can make it smaller more, and then I have propanol here. It is also small, and then we have this propanol and another molecule of this ethanol and another molecule of ethanol. Let's say we have two molecules of ethanol in a beaker like this. Let's just assume, and then we have also two molecules of propanol in a beaker, and we have it this way, and we want to apply heat to each beaker. When we apply heat to this beaker, we are trying to separate the molecules. We are taking away this molecule from this molecule. That's what we're trying to do. We're taking away this molecule from this molecule. We know when they separate, the substance will boil and then it will evaporate. The same thing we're trying to take away this molecule from this molecule. So let's say what join this molecule to this molecule is just this dotted line, this bond, this weak bond, and then we have the weak bond here. So if you check, if I make it big, we'll see that we have like 3 weak bonds here that link these molecules together, and we have 4 weak bonds that link this molecule together. So it means you have more bonds to break in order to separate a molecule of propanol from each other, compared to the bond you are going to break if you are separating the molecules of ethanol. So that is why you will exert extra heat energy in order to get these molecules separated, that is propanol separated. And that is why this one will have higher boiling point and at the same time higher melting point compared to this. And generally, the chain length of this is more than the chain length of this. So we have only 2 carbon atoms joined together in your ethanol. But in this case, we have 3 carbon atoms joined together in propanol. So chain length increases as you go. The next one is going to be, you have something like this. So as the chain length increases, the boiling point and the melting point increase at the same time, and also the viscosity increases, and at the same time flammability is it going to increase or decrease? Flammability will decrease as the chain length increases. So that is the properties of homologous series. We talk about the general molecular formula. That is, we said they all have the same general molecular formula. And we also said that the chain length of a homologous series, that is, of a family within a homologous series, increases by one unit, which is a CH2 unit. And also, we said as the chain length increases, the melting point increases, the boiling point increases, the viscosity increases, they get thicker as you go down the series. And then we said flammability decreases, they get heavier, and then they don't boil, they don't do what? They don't burn easily as they get heavier. So that is everything about homologous series. So thank you so much, and see you in the next part of the series.